Okay. So, what we're looking at today is converting fractions to decimals. The process of doing that is focused around the long division or the bus stop method. The only difference is when we get a remainder, we don't stop, we use the decimal point to continue. So, we'll just go straight in to a few questions and see how that all works. So, we go into the obvious one, 1/2, and how we can convert that to a decimal. So, bottom number goes on the outside, top number goes on the inside. So we do 1 divided by 2. So, how many 2's are in 1? Okay, so that's 0. Okay, now, of course, if we're going to stop to find a remainder, this would be 0 remainder 1. But that's not the goal, we want to continue. So, we don't have any more numbers, so we put a decimal point. Okay, that decimal point allows us to add 1 extra 0 and then check if it works. So I add my extra 0. So, that's 10 divided by 2 now. So, how many 2's in 10? If you go through your times table, that's 5. Okay, and as such, put 10 down here, subtract, that's 0, so no remainders. So, 1/2 as a decimal is 0.5. Okay, now let's take it a little further. Let's go for something more difficult, 3/8. Okay, the bottom number goes on the outside, top number goes on the inside. So, we start with 3 divided by 8. So basically, that's how many 8's in 3. That's 0. Now, we don't want to stop, we want to continue. So we need more numbers. So we put a point, decimal point as we call it, that allows us to add a 0 and check if we can go on. So, we divide 30 divided by 8. Okay, how many 8's in 30? If you go through the 8 times table, you'll find yourself at 3. That makes 24. So we get 6. Now, do we add another point because 6 divided by 8 is 0? No. The decimal point allows us to add 1 0 every time and check. So we just add a 0 because we're behind the point one time and then check it. So we say 60 divided by 8. How many 8's in 60? Go through the 8 times table. That would be 7, making 56. So we subtract again. That would be 4. We can add 1 0 and then check. We're behind the decimal point, remember? So 40 divided by 8. You go through the 8 times table. That makes 5. 8 and 5 make 40. And so we end up with zeros finally. Now, if I go through another question, 2/25. Okay, bottom number goes on the outside, top number goes on the inside. So, how many 25's in 2? That's 0. We want to continue. We need more numbers. So we put the point, and it allows us to add 1 0 and check. Now, how many 25's in 20? That's still 0. This time, because we've added 1 0 to the point, the free 1 0 that the point gives us, okay, and we checked, it's still 20 divided by 25, that's still 0. There's no 25's in 20. So, we put that 0 there. So we add another 0. We then say, how many 25s in 200? Okay, if you go through the 25s times table, that's 8. And so we subtract, and that's zeros. Okay, make sure you take your time with this one, understand what I did with the decimal point, and then adding the zeros. Very important. Now, if you notice, most of the numbers used, or fractions used, okay, were proper fractions. Now we're going to use improper fractions and see if the process is the same. So let's try 15/4 as a decimal. Once again, bottom number goes outside, top number goes on the inside. So, pick the first number. How many 4s in 1? That's 0. We have a second number, so we try for 15. How many 4s in 15? Go through the 4 times table. That would be 3. Okay. So that makes 12. We subtract. So that's 3. But we don't want to stop because we have a remainder of 3. We want to carry on. So we put a point that allows us a 0. How many 4s in 30? Okay, if you go through your 4 times table, you will find out that that's 7, which gives you 28. You subtract, you have a 2. Now, because we are behind the point, remember we always have a free additional 0, and then we check that. 20 divided by 4, that's 5, which makes 20 with 4. We subtract, that's zeros, so we can stop. So 15 divided by 4, or 15/4, as a decimal is 3.75. Okay, once again, let's try 23/5. Bottom number goes on the outside, top number on the inside. Start with the first number. How many 5s in 2? Not really any, so that's 0. So we check the 2 numbers. How many 5s in 23? If you go through the 5s times table, that would be 4, which creates 20 with 5. So we subtract, that gives us 3. We don't want to stop there, we want to carry on. So we have no more numbers left, so we put a point, and that allows us a free 0. Okay, so how many 5s in 30? Go through the 5 times table, that's 6. 6 and 5 make 30. You subtract, that's zeros. And so 23/5 is basically 4.6. Okay? Okay. Now, when we deal with a case where we have mixed fractions, okay? So for example, 1/2/5, okay? 1/2/5 can be expressed as 1 plus 2/5, okay? So to convert it to a decimal, all you have to do is convert the proper fraction to a decimal and then add it to the whole number, okay? Like so. We find the decimal of 2/5. So 5 goes on the outside, it's the bottom number. 2 goes on the inside, it's the top number. Okay? How many 5s in 2? That's 0. We want to carry on. So we put a point. That gives us a free 0. How many 5s in 20? Go through the 5 times table. That's 4. That makes 20. We subtract. That's zeros, so we can stop. So 2 over 5 is 0.4. Now, all we say is 1 plus, instead of 2 over 5, we use the decimal version, 0.4. And so, 1 over 5 is the same as 1.4. Okay? Now, try that again. 3 over 4. The mixed fraction can be expressed as the whole number plus the proper fraction part of it, 3 over 4. So all we have to do is convert this fraction into a decimal and add it to the whole number. So 3 over 4, that's bottom number 4 on the outside, top number 3 on the inside. Now, how many 4s in 3? That's 0. Okay, we want to continue, so we add a point. That gives us a free 0 in here. How many 4s in 30? Go through the 4 times table. You find out that's 7. 4 and 7 make 28. We subtract. That gives us 2. Now, because we're behind the point, we get one free 0. So, get a free 0 again to continue. How many 4s in 20? That's 5 if you go through the 4 times table. 4 and 5 make 20. So we subtract. That's both zeros. Okay? So, 3 over 4 is 0.75. So we come back over here and say 3 plus, instead of 3 over 4, 0.75. And then that's 3.75. Okay, that's how you get it done in converting fractions to decimals for proper, improper, and mixed fractions. Okay, thank you very much. You've been listening to the Math Done, and until next time.